Well, now let's look at 6 graphing examples of linear inequalities. And I think the first one we'll start with is this one. It's a little bit simpler than the others. Notice that this is already in y equals or y greater than or equal to mx plus b form. We have y all by itself on the left. But there is no x value, which means the slope, m, is a 0. So if we do as the instructions said, we first write the line y equals -3, which happens to be a horizontal line. And I'll make a note, we use a solid line because it's the greater than or equal. And we already know if we're going to do the upper half plane or lower half plane because y is greater than or equal, which means the upper half plane. So if we graph this horizontal line, we go down 1, 2, 3, -3. That's our line. And then we shade the upper half plane. As simple as that. If it were y less than or equal to -3, we would have shaded below this horizontal line. Now let's go to the first one here. Y plus 5x plus 2 is less than or equal to 0. First thing I want to do is rewrite it so we have y all by itself on one side. Y less or equal. I have to subtract 5x from both sides, and I have to subtract a 2 from both sides to get these, to eliminate them from the left side. So it would be y less than or equal to -5x minus 2. Once again, all I did is subtract 5x from both sides, and I subtracted 2 from both sides. Well, now I can tell right now that I'm going to use a solid line because it's got the equal part in the inequality, less than or equal. And what else do I know? Am I going to shade an upper half plane or a lower half plane? It's less or equal, so I'm just going to put lower half plane just as comments. So now let's graph y equals -5x minus 2 and use a solid line. So the y-intercept is -2, which is right there. And then the slope, m, is -5, which is -5 over 1, which is the same as 5 over -1, either way. So I could go down 5 to the right 1 or up 5 to the left 1. I'm going to go up 5 to the left 1 because I have more room that way. Up 5, 1, 2, 3, 4, 5 to the left 1. And then let's draw that line. And we used a solid line. Now, when these lines start getting close to being vertical, you need to be a little careful. Which half plane is the lower half plane? Well, one way of doing it is just take any point on the line, and if I draw straight down, I'm in the lower half plane. So I know the one that's it looks like almost on the left-hand side, but it's called the lower half plane. So this is the half plane that I shade. That's the solution. This would be considered the upper half plane because if you started with a point on the line and drew straight up, you're in this region. That would be the upper half plane. Okay, so this is maybe a tricky one. There's no y value, so we can't put it in slope-intercept form. Let's see what we know about this. Well, the line would be x equals -4 because you change the inequality into an equal sign. What kind of a line is this? When you don't have a y, you just have x equals a number. Well, that's a vertical line. So we go find the y-intercept, I'm sorry, the x-intercept actually, at 1, 2, 3, at -4, right here. And the vertical line, oh, I need to do dotted line because it's a strict inequality. There's no equal sign there. So that's the line. And it's probably what you think. X, remember, tells you left and right. If it's greater than, you have to go to the right. So we're going to shade the right region. So there is no upper half plane and no lower half plane when you're dealing with a vertical line. It's only left and right. It's a very, very special case. Just remember, anytime you have an inequality just with X, it's going to be a vertical line, and then you shade either the left or the right. Okay, let's get down to the bottom three. Okay, once again, I think I'll start with the middle one because it looks like it's the easiest. So it's a greater than or equal, and it's already in y equals mx plus b form. We have y by itself on the left. So it's a greater than or equal, so it's got the equal. I know I'm going to do a solid line. And it's greater than, so upper half plane. So the line we're going to draw is y equals negative 2x, and solid line. So the y-intercept is 0. You can see what this is like y equals negative 2x plus 0. And then the slope m is negative 2 over 1, negative 2. You could also write that as 2 over negative 1. So I can either go down 2 to the right 1 or up 2 to the left 1. Let's do both. From this origin point, I'm going to go down 2 to the right 1. Or if I start with the origin and go up 2 to the left 1, we get this point. And we could continue and get that point, continue downward and get that point. So I need to use a solid line. And we do the upper half plane, which is in this direction. And just as a reminder, what this means is that every single ordered pair that is on the line, or in the upper half plane over here, if you take those ordered pairs, like for example this ordered pair, 1, 2, 3, 4, 1, 2, 3, 4, 4, if you plug it in, it's going to succeed. It's going to satisfy this inequality. If you choose one in this section, say this point right here, negative 2, negative 2, it will not satisfy this, because if x and y are both negative 2, that would give us negative 2 greater than or equal to negative 2 times negative 2 is a positive 4. Negative 2 is not greater than or equal to a positive 4, so we do not shade this region. I shouldn't even have put that dot right there. So the solution is every point on the line or any point in the this half plane we shaded. Okay, let's go to this one on the left. First thing I'm going to do is solve this so I have y on the left-hand side. Solve it for y, get y on the left. So I would have 4y less than, I'm going to add x to both sides, and I'm going to add 12 to both sides. X plus 12. And then divide everything by 4. And that gives us y less than 1/4 x plus 3. So this is the same inequality as this. We just rewrote it in the slope-intercept form where we have the y on the left-hand side. So it's a strict less than, so that means I'm going to do a dashed line. I think I wrote dotted before, but dashed or dotted. And it's a less than, so I'm going to do the lower half plane. So with a dashed line, let's draw y equals 1/4 x plus 3. Replace the inequality with an equals. So if 3 is the y-intercept, that's that point. And then what do we have? A slope of 1/4. So m, let me write it up here. M equals 1/4, so I'm going to go up 1 to the right 4, or I could go down 1 to the left 4, because that's also equal to -1 over -4. Remember, the negative signs cancel. So here's our line, and I need to use a dashed line. And let's see, we noted below that since it's a less than, we have to do the lower half plane. So that's the solution. Everything that's below, or everything that is below that dashed line is the solution. Note that the points on the line are not part of the solution, because they wouldn't give you an inequality, they would give you equals. For example, if you plugged in the point 0, 3, which is on this line, but it's a dashed line, so it should fail here. If you plug in a 0, 3, you would get a 0 for x and a 3 for y. You would get 12 minus 12, which is 0, and 0 is not less than 0, it's equal to 0. So the points on this line are not part of the solution, as they are with, say, these two. If they're on this line or this line, they are part of the solution. That's why we used solid lines up here. Okay, our last example. First thing I'm going to do is rewrite it. Y strictly less than 1 over 5x plus 2. I simply added 1/5 x to both sides. So this tells me that we're going to do a dotted line because it's a strict less than, and we're going to shade the lower half plane because it's less than, it's not greater than. So the line would be y equals 1/5 x plus 2, which means our slope is 1/5, up 1 to the right 5. So let's plot our y-intercept, 0, which is 2. And then the slope being 1/5 means I can go up 1 to the right 5, or I could also go down 1 to the left 5, down 1 to the left 5. And I'm using a dashed line. And this was a less than, so it is the lower half plane. And that is the solution. This lower half plane is the solution.